Hi and welcome to another video for additional maths year 9. So this one is still on chapter 7, equations, inequality and graph. And today we are going to deal with how to solve more complex quadratic equations. So over here basically you have to know how to use substitution for forming another quadratic equation that you can solve as of more examples over here that is more complex. Okay, now we can solve an equation that is quadratic in some function of x. So for example, over here, as you can see here, there are equation that will be giving you x into the power of something else. But you can see here, for both x power 4 and x power of 2, this actually can be substituted into another alphabet. So for example, the lowest number or the lowest power of x over here is x squared. So let's say we substitute as m, which makes x power 4, which is x squared, the power of 2 will become m squared. So this one, your new equation for the quadratic that you have over here is actually 4. And x power 4 will be replaced with m squared minus 17 x squared as m and plus 4 equals to 0. So there you have it, according to the equation. But let's have a look at the solution first. Okay, so for this one, it can be factorized by double bracket. And here, the number 4 is going to be here. And minus 1 minus 4 equals to 0. So for both m, okay, you have this number. So this is not your final solution yet because you are supposed to solve for x. So over here, you have to return the m back into x squared. So here, x squared for both equation, x squared equals to 1 over 4. And the second equation is x squared equals to 4. So this one, just a final step that is involving square root of x squared. So this one, if you want to solve for x, you must both square root both sides of the equation I have here. So therefore, for the first one, your first x solution is half. But because the square root has a plus or minus, so here you actually have two solutions, which is positive half and negative half. And as for the second one, x equals to both positive and negative 2. So that's for the first example. Okay, let's have a look at the next example. Use the substitution y equals to x power 1 over 3 to solve this equation. 3x to the power of 2 over 3 minus 5x power 1 over 3 plus 2 equals to 0. So you can see here, you already have what you will substitute over here. So x power 1 over 3 will be y, okay, later. And for this one, x power 2 over 3, it is x power 1 over 3, and then another power of 2. So which means this is a y squared. So you can see here, both x power 2 over 3 and x power 1 over 3 can be replaced with y and y squared. So 3 power x power 2 over 3 will be 3y squared minus 5. X power 1 over 3 is a y plus 2 equals to 0. So this one can be factorized. So here you will have 3y times y, but then the 2, I will put it here. So you will have 3y minus 2 bracket y minus 1, which means the first y is 2 over 3, and the second y is 1. But for this equation, the real solution that you are going to solve for this equation is x. So you have to take back the y and the y square over here. So y over here must be replaced back into x power 1 over 3. Right? So here for both equation, x power 1 over 3 is 2 over 3, and x power 1 over 3 is a 1. So here, in order to solve this x power 1 over 3, let's take it to a power that is a reciprocal of 1 over 3. So reciprocal of 1 over 3 is power of 3. So which means both sides can be applied with a cube. So over here, both sides are already in the cube. Okay, so you can see here x power 1 over 3 power 3 will give you back x power 1, which is the solution. So the right side over here is 2 over 3 cubed. So if you cubed 2 out of 3, it will be 8 over 27. And as for the second solution, x equals to 1 cube is always 1. So there you have it. This is your next example. Okay, let's have a look at the next example. So here you have equation of x minus 4 square root of x minus 21 equals to 0. So over here, say, because you know this is a power 1 and square root of x is x to the power of half, so it is a smaller power. So let's say if we let x equals to, let's say, m, which means if you square root of x, that will give you x, which means this x power 1 is an m square. Right, okay, I forgot to give the square over here. If you square root of x, then you will get the x, which is this one. It will be m squared. So over here, your new equation will be m squared minus 4m minus 21 equals to 0. So this one can be factorized. M minus 7 and then m minus 3, plus 3, sorry, equals to 0, which will give you m equals to 7 and m equals to 3. So this one, m must be written back or replaced back with square root of x. It's because this is your real solution for this question. So here square root of x equal to 7, and the second one is square root of x equals to 3. So here, this one, if you want to cancel the square root, the opposite of square root is a square. So here, we apply square on both sides of the equation that you have over here, because we want to cancel the square root before x. So here, the first x is 79. Is 79, sorry. This is 49. Okay. The first solution, and the second solution is 3 times 3 is a 9. So this one is your example 3. Alright, so let's move on to the last one. Okay, here you have solved the equation 8 bracket 4 power x minus 33 minus bracket 2 power x plus 4 equals to 0. So here, this equation, if you can see, 4 power x and 2 power x, let's choose the lower base, which is 2 power x, to be replaced with an alphabet. So another alphabet over here, let's say I'll take m to be consistent over here. So the 4 power x can actually be replaced with m, but you have to modify the 4. So 4 is 2 square, and then the power x is still there. This one is actually can be swapped with each other. So you will have 2 power x power of square, and there you have it. 2 power x is your m on the next one. So 4 power x is m squared. So this one, the first term over here, 4 power x can be replaced with m squared minus 33 to the power x is m plus 4 equals to 0. So here, this is a quadratic equation which can be factorized. So here, this is your second one. So 8m minus 1 bracket m minus 4 equals to 0. So your first m is 1 out of 8, and the second m is positive 4. So here nothing's too weird. So the m here must be replaced back with 2 to the power of x because that's your real intent of the question. So 2 power x is 1 out of 8, and the second one is 2 power x equals to 4. So this one, you can see this is a simple base of 2, so 8 is actually a power of 2. So 2 power x equals to 1 over 2 power of 3. So this one, 2 power x, the 2 to the power of 3 in the denominator, you can bring it up to the numerator, but you have to change the power sign. So here the sign of positive 3 becomes negative 3, and as for this one, 2 to the power of x equals to 2 to the power of 2. So now there we have it. The solution for both x is, the first one is a negative 3, and the second one is x equals to 2. So there we have it. So this is the last example for this topic. Solving further or solving a more complex quadratic equation. So with that, that's all for that video. So I hope it will help you. Thank you very much and see you in the next video.